This is a cat. Adorable, right? More like incredible. Incredible that your brain saw this jumble of pixels and thought, yeah, that's a cat. The power our brains hold to distinguish things is one of the great gifts of life, and we do it every day. So, we can do it, but how can a computer do it? How can a computer recognize objects like dogs or cats in pictures? The answer? Neural networks. Neural networks are computer programs inspired by how our brains work. Just like our brains have billions of tiny cells called neurons, neural networks have virtual neurons. These virtual neurons are very simple. Think of it as a cell that holds just a single number. These cells work together to learn and recognize different objects, similarly to us. However, it is important to discuss the difference between neural networks or artificial intelligence and us humans. People often think that visual neural networks and other types of AI, such as the mighty ChatGPT, think and make choices like a person. However, that is completely wrong. If they do that, the end is probably near, and we should probably all run for our lives. Anyway, visual neural networks have a similar virtual structure to humans' brains. However, it only emulates specific parts and is generally just a randomized structure that learns a function representing the different patterns of images, so not so much like a brain. Other AIs, such as GPT, are called transformers, since they learn meaning through analyzing patterns in sentences. In essence, it's important to remember that these AIs are just algorithms and don't have any thought similar to humans. Yet. Now that we've explored some of the differences between visual neural networks and humans, let's dive into the understanding of how visual neural networks work, and more importantly, how we can teach them to recognize cats. For a neural network like this, learning comes in two stages: training and testing. Imagine you want to teach a computer to recognize a dog. In the training stage, you would show it many pictures of a dog and tell it, this is a dog. The network looks at the pictures and tries to understand what makes a dog a dog. It learns to recognize patterns, like the shape of the ears, fur, and the tail. The network does this by strengthening the weights between its virtual neurons. It starts with random connections between the virtual neurons and doesn't know much about the objects it needs to recognize. Looking at the network, it starts on the left with a neuron for every pixel of the image, for example. Then it goes from the first layer to the hidden layers, where the processing happens. Each neuron stands for different hard-to-understand abstractions and patterns, which come together to decide by the final layer which category it fits in. If it chooses dog, for example, it'll activate this neuron, and it'll hold a number from 0 to 1 depending on its certainty. During training, the network is given an entire set of labeled pictures, which means that each picture has a tag that tells the computer what object is in the picture. Let's say we want to teach it to recognize dogs. The network looks at the pictures and makes guesses based on its random connections. It compares its guesses to the correct labels. Then, the computer adjusts the strength of the connections, called weights, based on the mistakes it made. If it thought a cat was a dog, it changes the weight so that the mistake doesn't happen again. It keeps doing this over and over, looking at more pictures, making guesses, and adjusting its weights. Through this process, the computer becomes better at recognizing objects. Graphically, its recognition can be visualized by a decision boundary. Basically, what this means is that the algorithm approximates the closest function to correctly identifying the images and creates a boundary between them. For example, we want to make sure our computer makes decision boundaries correctly between images of dogs and images of cats. It learns to assign the right weights to the connections between neurons so that they can work together to recognize patterns accurately. Once the neural network has learned to recognize dogs, it enters the testing stage. You can show it a new picture outside of its training set, and it'll tell you if it sees a dog or not. It looks for the patterns it's learned and makes a guess based on what it knows. Sometimes it might make mistakes, just like we do when we're learning something new. But with practice and more training, the computer gets better at recognizing objects. There's also the concept of generalization versus accuracy. And I know that sounds complicated, but listen to me here. If a network is super accurate, it might not be able to generalize new images that well. For example, if the network is only trained on one type of dog, like Chihuahuas, it'll be very good at telling what a Chihuahua is, but maybe not that good at other types of dogs. However, if it's too general, and we let it train on all types of dogs, it could run into the problem of taking any four-legged animal as a dog, and then its accuracy isn't so good. And you can run into even more problems. Even a network that seems to be really well trained isn't perfect. Remember, these networks don't think like us. Therefore, sometimes a pattern that matches a category isn't always for the right reasons. Look at this picture. A grassy hill, right? Wrong. It's a sheep, obviously. Or this. Outstretched legs? Nope. It's a soccer ball, obviously. A trained neural network often takes shortcuts to come to the answers, taking the path of least resistance, the easy way. Something in the background of an image is usually a pretty good indicator of what the image is about. It's important for the long-term health of the algorithm to try and avoid these shortcuts. The range of possibilities provided from just visual neural networks are boundless, and we haven't even talked about any other type of model, like language models like ChatGPT. We've gotten to the point where visual neural networks are better at recognizing human faces than most humans, beating out even face experts. Yes, those people exist. The coolest part? Click on the link in this video to go to our website and mess around with a network yourself. You might learn a thing or two, or at least you could teach the network to learn a thing or two. Have a great day. Bye.